Hello! We're going to do a lesson today on significant figures. Part 1, the rules. Significant figures, just so you know, can also be called significant digits, or sometimes they're called sig figs or sig digs for short. So what we're going to be doing today is we're going to define what significant figures are, then we're going to explain why they are important, and then we're going to list 5 rules for identifying significant figures, and then we're going to practice counting the number of significant figures and measurements using those 5 rules. So first thing that we need to write down is the definition of significant figures. Significant figures, or sig figs, include all known digits plus one estimated digit. So here the example is that this pencil has a measurement of 6.7 centimeters. And we say that this has 2 significant figures. And we'll explain why in just a moment. So when I'm looking at this ruler, what I want you to see is that we can measure exactly to the 6 centimeter mark. But then we can tell that it goes a little bit past that. Now about how much past, we're not totally sure, so we're going to estimate it. So that's why it says all known digits, so the known digit is the 6, because we can see it right here, plus one estimated digit, so that's the 0.7. So we can see that it's a little bit farther than halfway, so probably more than 0.5, 0.6, 0.7, maybe even 0.8. So we're not completely sure, but it's a good estimate. Okay, now the reason that this matters is when we tell somebody else a measurement that we did, something that we measured, whether it's with a ruler or perhaps with a scale like this one, we want to be able to explain how exact that measurement was. Are we having to round off to the closest centimeter? Are we able to see all the way down to the millimeters? Maybe we're even more precise. In labs, scientists can actually measure to 0.0000000 19 zeros and then 1. So really super precise. So we're trying to explain how precise or not precise our measurements are. So now we're going to list the 5 rules. So you need to write down these 5 rules, and I would leave some space so that you can write down the example for each. So for rule number 1, all non-zeros are significant. And non-zero numbers are just numbers 1, 2, 3, 4. You see them listed here. You know, all of those numbers. They're always going to be significant. We always count them. The zeros are the only ones where you really have to think about it. And so the next 4 rules are just going to be about figuring out the zeros. So my first rule about zeros is anytime they're between 2 significant figures, we always count them. And it doesn't matter how many zeros are in between. You can see here that there's actually 4 zeros between the 8 and the 7. And all 4 of those zeros actually count. So this particular number right here has 6 significant figures. So both of these non-zeros and then all of the ones that are sandwiched all count as being significant. Okay, my next rule is that leading zeros are not significant. And leading zeros are any of the zeros that come before your first non-zero number. So we only see that happen when we actually have like a decimal. Like for example, I wouldn't write 0000500 and call that 500. That doesn't make sense. You wouldn't have all of those extra zeros. So you're only going to see leading zeros if you have like 0.5. There's 1 leading zero. I could say 0.05, and I've got 2 leading zeros. 3, 4, you see what's going on there? All of those leading zeros are always going to be not significant. Oops, excuse me. There we go. Okay. Now the zeros at the end of a number after the decimal place are significant. And you know what? I'm going to actually highlight this after right here because that matters. So they've got to be at the end meaning that they came after a non-zero number, and after a decimal place as well. So that's rule number 4. Zeros at the end of a number after the decimal place. So it's like 2 rules in one. End and after the decimal. Now, if we have zeros at the end of a number, but there's no decimal place, like in this example, 300 million, those are called trailing zeros. And trailing zeros, like leading zeros, are not significant. So none of these zeros here are significant. So we would actually say that this number, 300 million, only has one sig fig, just the 3. This is an example of scientific notation where we're showing that this actually would have 8 zeros after it, but we're just writing it this way to save some space. So remember when we learned about scientific notation, we're using that same skill right here. And this number actually, 300 million meters per second, is the speed that light travels. So it can travel 300 million meters every 1 second. And that's a not very precise number because we're rounding off to the closest 1 million. So that's really, really not exact. They've actually measured it to be pretty exact. They've gotten it, scientists have measured that light can travel 299,792,458 meters every second. So they've gotten it down to the closest meter, which when we're talking about light and we're talking about a number that big, that's actually pretty precise. So they haven't gotten it down to like millimeters or anything, but that would be really, really hard. So this is pretty good. Okay, this is just kind of a summary of the sig figs. So zeros are not significant before the decimal and before a non-zero number. So all of those, remember we called these leading zeros. Then these non-zero numbers are always significant. And then the zeros that come after numbers and after a decimal are significant. If there were some zeros in there between the 3 and the 4, those would also be considered significant because they'd be sandwiched. Okay, time to do some practice. We're going to count how many sig figs are in each of the following numbers. So take a look at number 1. Remember your rules. Take a look at your rules and see if you can figure out how many sig figs are in this number. So the correct answer is technically 2. This 0, since it's an ending, since it's a trailing 0, there's no decimal point here. So we would call that one just 2. And this word ambiguous, it means that we're not necessarily sure. Maybe there's an implied decimal place there, but we don't know. So we have to always err on the side of not knowing. So we're going to say just 2. How about in our next number, 0.710? Well, that one has 3. So we don't count the leading 0. We always start counting our significant figures at our first non-zero number. So 7, 1, and then because this comes after a non-zero and after a decimal point, we get to count it. So this one has 3. How about the third one? That one has 6. So we know that the 8s are both significant. This 0 comes after a non-zero and it's at the end of the number. And then these 3 are all sandwiched in between. So they all count. All right. Number 4, how many in there? Correct answer is 3. So none of the leading zeros, and none of them count. So all of these are insignificant. The 4 and the 5 are both significant, and then this 0 is sandwiched, so it is significant. So it's just these 3. Now our last number here, 3.80 times 10 to the 8th. Just as a reminder, what that would mean is 380 million. So we would move this decimal place over 8 places. So 1, 2, and then add 6 more zeros. And so this, we're just going to count the numbers in this number here. We don't worry about any of this. So we're just going to count these. So we've got the 3 and the 8, and then since this 0 comes after a non-zero number And at the end of the number, we know that that is significant. So that one's 3. Now, when we are measuring, remember that your last digit is always considered uncertain. Last thing, this is a chart that you can use to kind of help yourself figure out, is something significant or not. If you like this chart and you feel like you would like to use something like this when you're working, instead of just looking at the list of rules, we have some laminated copies of this in class. So if you'd like to borrow one while you're in class, you can do that. Or if you're working on homework and you want to come and ask for one. Or if you want to take a screenshot of this, you can do Command-Shift-3 to do the whole screen, or Command-Shift-4 and get just a portion. You can reach over and go click and drag all the way across. And you can do that. So finally, I just want to get quick feedback on what you thought of this significant figure stuff. Do you feel like you don't understand it at all? Do you feel like you really need a lot of help? So 1. 2, I think I understand, but I may need some help. 3, you're on your way, but you don't need help right now. You'll get there. 4, I get it. And 5 is the best. Can you actually teach this lesson to somebody else and have them understand it? So let me get your feedback, and I'll see you guys in class.